Alright, boys and girls, I'm back. Next video here, 6.3, is titled Anti-Differentiation by Parts. Okay, so let's review really quickly before we get too far into this. Just want to review what we did in the last section. Last section we talked about integration by using substitution. Alright, we looked at definite integrals and indefinite integrals, both. So integration by substitution is useful when you have compositions of functions. So if you have a function inside of another function, that's when you should probably use integration by substitution. Now it's just a rule of thumb. Not necessarily always, but rule of thumb, look to substitution. Now, rule of thumb, using integration by parts, what to look for is when you have a multiplication problem. All right? So if you're multiplying two things. Again, not always, but most of the time when we use integration by parts, it deals with, maybe I need to rephrase that. Integration by parts is the best method to choose when we are multiplying. Okay? So when we have two things being multiplied and we're trying to take the integral of it. So where it comes from, I'm going to show you right here in this video why the integration by parts. There's going to be some formula why that formula is true. Okay, so we're going to derive the formula for integration by parts, and it comes from, if you guys noticed right here, write this down. This should look familiar. What rule is that with derivatives? If we take the derivative of something times something else, you should know that's the product rule. It's ABBA. Remember when we talked about that? We talked about it being ABBA. The reason I wrote it like this is because it's easy to remember. Okay, but your book writes it with U's and V's. So what I'm going to do is I'm going to translate this into just U's and V's. So it's essentially the same thing. We're just going to change the letters. Instead of A and B, let's use U and V. So if we want to take the derivative of two things being multiplied, instead of A and B, let's just do U and V. So this is going to be V, my bad, wrong. Instead of A prime B plus B prime A, it's going to be U prime V plus V prime U. Now, I wrote it with A's and B's because ABBA is a lot easier to remember than UVU. Alright, so I think so at least. They had some good songs, ABBA did. So let's keep this going. Now, this isn't the notation I want to write this in, so again, what we're trying to do, the reason I'm doing this is because I want to try to get to the integration by parts formula. All right, I want to try to explain where that comes from. All right, so I don't want to just give it to you and accept it and move on. I want to explain why it works. All right, so here we go. So what if I took this and I rewrote it in a different notation? I'm going to keep everything over here on the left side the same, but instead of those primes, let's say we wanted to write it in Leibniz notation. Now, if you remember Leibniz notation, it's when we talk about dy over dx, all the d over dx's, all that stuff. So instead of writing u prime, that's the same thing as the derivative of u with respect to x. Okay, so it's going to be du over dx. That's how we can rewrite that. It's just different notation there. I'm going to leave v alone, so times v, plus v prime, we can rewrite it as, well, it's the derivative of v with respect to x, so it's going to be dv over dx. And we still have this times u. Alright, so just bear with me here, guys, and again, I'm just trying to show you where it comes from. What you need to ask yourself is, everything that I'm doing here, am I allowed to do it? Right? Mathematically, is it solid? Is it good logic? So, as long as you can answer that question with yes, that's all you need to know for right now. In terms of why I'm going to do this stuff, you might be confused as we go through this, but just bear with me, it'll become clear when we get to the end. Okay, so, are we allowed to do this? So what if we wanted to move this term to that side? How could we do that? Well, just for fun, if we wanted to move that over, we would need to, well, it's being added, so in order to undo that, we subtract it. So let me do that. So again, are we allowed to do that? Hopefully your answer is yes. We're allowed to subtract anything from one side as long as we do it to the other. Okay, so these will cancel right here. And what we're going to be left with on this side is going to be d over dx times uv minus du over dx times v. And that is going to equal, let me get out of the way, dv over dx times u. All right, we just have that whatever's over here, whatever we have left. Okay, we haven't touched that stuff. All right, so hopefully everybody's with me up to this point. Again, you might not understand why we're doing that, but I'm allowed to do it. That's what you need to know. Okay, that's all we need to know right now. So let me scroll back up so you guys can see that. All right, so all we've done is move that over. Now, guys, the integration by parts formula is a formula that deals with integration. This is all derivative stuff. So, again, just for fun, for kicks and giggles here, what if we wanted to integrate both sides? Well, as long as we do it to both sides, we're allowed to do that. So here we go. Let's integrate both sides. So when we integrate both sides, we've got to integrate every single term. And we're going to take the indefinite integral, okay? We're not concerned with the area under the curve right now. I'm just trying to introduce the formula to you. So let's take the indefinite integral of this formula, d over dx of uv. And whenever we do this, guys, let's write down what we're doing first, just so you have this in your notes. We're going to integrate both sides with respect to x. Okay? Integrate both sides with respect to x. So when we do this, whenever we choose to integrate here, we always need to know what variable to integrate with respect to. So in this case, we need to integrate with respect to x. So to denote that, we always have to write this with dx. If we want to integrate with respect to y, it'd be dy. If we want to integrate with respect to z, it'd be dz. Okay, so hopefully that makes sense there. Now we've got to integrate everything, so it's going to be minus the integral of du over dx times v. And we still have this dx. We want to integrate that with respect to x. We've got to do the same thing to the right side, so it's going to be the integral of du dx times u dx. Okay, so now let's keep it going. Now we're not quite there yet. We're not quite to the integration by parts form. We've got to keep cleaning it up here. So here's what I want you to think about. All right, so look at this notation. This notation right here means what d over dx means is take the derivative of. Okay? It's essentially a command. It says take the derivative of uv. And this elongated s, what that means is take the integral of. So guys, we're going to be taking the derivative and the integral at the same time. So what's going to happen is that those are going to cancel each other out. And what we're going to be left with is just uv. Okay? So if we take the integral of the let me say that again. If we take the antiderivative of the derivative, those two cancel each other out. Okay, so it gives us uv. All right? So, that's that. Now over here, let's try to, what I'm going to say here, guys, these are fractions, so let's pretend like these are, fractions. I know they look like fractions, du over dx notation, so they behave like fractions. So guys, think about this. If I have a dx over 1 and I have dx in the denominator here, what's going to happen with those is that they're going to cancel. So this is going to be minus the integral of, well, it's going to be du times v. Well, couldn't I rewrite that as v times du? Okay. So all I did is I canceled my dx's here in that case. And then the next thing, I'm going to do the same thing on this side. So it's going to be the same thing as the integral from, I think I wrote something wrong, guys. Let me make this correction. Yep, you guys were probably yelling at me this whole time. What was this originally? It was dv over dx times u. So correct this mistake. Hopefully you noticed it. If not, we'll fix it now. That should be dv over dx. Let me scroll down here. Alright, so there we go. So we're still going to do the same thing here. dx's are going to cancel. And so what we're left with is dv times u, which you could rewrite as u times dv. Okay, that right there is the integration by parts formula. All right, we could stop right there if we wanted to, but usually we write it like this. So we could say or, we could just flip them. Okay, so we can write this one first on the left-hand side. So the integral of u dv is going to equal uv minus the integral of v du. box this up. This is important. This is our integration by parts formula. Alright, so good news here. If that stuff that we didn't make any sense, I tried to show you where this comes from, why this formula works, why it's true. It started all the way back from the product rule of derivatives. Right? We just wanted to go backwards and talk about antiderivatives. If that doesn't make any sense, the good news is, well, it doesn't have to. You can just accept that formula and move on. Right? So you can use this formula to find derivatives when you want to antidifferentiate by parts. I misspoke. Not derivatives, antiderivatives. Okay, when you want to antidifferentiate. Okay, so let's keep it going. Let's do one example. Let's try to at least. Hopefully this will make sense. Let's just start with one example here. So here we go. Now we're going to do a lot of practicals with this, so it might not make sense right away. Let me get rid of this stuff here, and we'll get to it. So write this down in a second. I've got a lot of stuff here, so give me a little bit. Okay. Pretend like you don't see any of this. All right, here we go. So write this down. We're going to do this one real quick. We'll do this one together here. I don't expect you guys to know how to do it right away. So here we go. Now, this first one, we're just trying to get the hang of this. Just trying to get introduced to you guys. So just bear with me, guys. It might not make a ton of sense right now. I'm just going to warn you. It might not make a ton of sense, but hopefully it does at the end. I'll go back and talk about it. Hopefully it does. So I see I've got multiplication here. I've got x times cosine of x. So like I said in the beginning of this video, I said that might be a good idea to use integration by parts. Okay. So it's telling me what to do here. It says evaluate this guy by parts. Okay. So what we need to do is pick a u. Now it's not going to make much sense right now. So what I mean here, let me go back here. Our formula, the integral of u dv is equal to this stuff. So that's why I need to pick a u, and I'm going to let the other quantity be dv. Okay? So again, might not make a ton of sense. Just bear with me here. I'm going to let u equal x. Okay? So this guy right here, I'm going to let that be u. U is going to be the same thing as x. Now, I'm going to let dv be this whole stuff right here. I'm going to let that be dv. So I want to write this integral. To use this formula, I want to write it as the integral of u dv. Okay? So I'm going to let x be u, and I'm going to let cosine x dx be dv. So down here, I'm going to write dv. Now, I'll explain that in a second. Let me kind of stagger it here. So let it be a line below and to the right of it. So dv would be cosine x dx. Okay. So now, in order to use this formula, what I'm going to need here, guys, look at what we have. I'm going to need to know what v is. I'm also going to need to know what du is. Okay? So, yeah, we know what u is, and, well, that's about it. We know u, but everything else, we need to know v, we need to know du. So we can figure that out, guys. Du is found by taking the derivative of u. So what's du going to be? Well, what's the derivative of x? Okay? The derivative of x is going to be 1, but I'm going to rewrite it as 1 dx. Okay, remember when we did that with substitution? Let me show you here, just to be thorough with this. Instead of writing like this, let me write it as du over dx. The derivative of u with respect to x is going to be 1, and then if I want to solve for du, multiply by dx to both sides, and so I get du is going to equal 1 dx or dx. Does that make sense? You can write it as 1 dx if you want to. Okay, so we know what du is going to be. Now, we also want to figure out what v is, so we're going to go backwards to get v. Remember, dv is the derivative of v, okay, and that's equal to cosine x dx. So if I want to go backwards, you need to think, what's the antiderivative of cosine? So what if I take the derivative of it will give me cosine? The answer is sine, okay? So guys, if I take the derivative of sine, I get cosine x. If I take the antiderivative of cosine, I get sine. Hopefully that makes sense. So I want to find all four of those things now so I can apply the formula. So I can rewrite this, the integral of, what is it, x times cosine x dx. Okay, let me change colors here. So didn't we let this be u, and didn't we let this whole thing be dv? Everybody agree? Okay, so let's just apply the formula now. So all we need to do is go back and use this thing. So it's going to be u times v. All right, so the integral of u dv is going to be u times v. So let me write down u times v. Let's look back here. What's u? Well, it's going to be x. And what's v? Sine x. So it's going to be x sine x minus the integral of, let's keep it going. Let me go back. Sorry, I didn't mean to scroll up here. Let me go back here. So what's the formula tell us to do? Minus the integral of v du. Okay. So what is v? V sine x. And what is du? Well, du is 1 dx. So can't we just write that as dx? Okay. We're getting somewhere. So let's do this now. Well, x sine x we really can't do much with. But we can do something with the integral of sine x dx. Alright, so you need to think about this. What is the antiderivative of sine x? Well, what function that if we take the derivative of it, we will get positive sine x? Okay, the answer, we still have the formula tells us a minus, but the answer is going to be negative cosine. Think about that. Remember, these are the ones I told you to memorize, sine and cosine. So, guys, if I asked you, what's the derivative of negative cosine? Well, the derivative of cosine is negative sine. So the derivative of negative cosine is negative negative sine, which is positive sine. All right, so if I want to go backwards, if I want to take the derivative of this guy, it would give me that, okay, positive sine. And one thing I'm forgetting, whenever we take the indefinite integral, we've got to have a plus c. Okay, so now we're almost done. It's going to be x times sine x. Minus the negative cosine is positive cosine. And then plus c. That right there is going to be our answer. That is the antiderivative of x times cosine x. Alright, so again, I'm not expecting this to be perfectly clear, but let me do one thing here, okay? One more thing, and that is check the answer. So guys, I know we've talked about this, but how do we check the answer? If we've done an integration problem, how do we check the answer? Well, to go backwards, we would take the derivative, okay? So what I'm going to do is I'm going to take the derivative of this and see if that gives me what we started with, okay? So remember, the antiderivative says, okay, what function that if we were to take the derivative of it, would it give us that, okay? So let's go and take the derivative of this function and see if it gives us that. All right, so hopefully that makes sense. So here we go. If I want to take the derivative of this first term, we got something times something, don't we? So we have to use what rule? In terms of derivatives, we have to use the product rule. So remember, we called it ABBA, so let's let A be x and B be sine x. So A prime would be what? Well, that's just 1. B prime, what's the derivative of sine? The answer is cosine. Okay? So I'm just going to find the derivative of this one first. So the derivative of x times sine x, let me do this in green, is going to be, well, a prime b, which is 1 times sine x, which is sine x, plus b prime a, which is cosine x times x, which is the same thing as x cosine x. Is everybody with me? So that's just this, the derivative of that we found. So that was using product rule here. Now what is the derivative of cosine? Derivative, not antiderivative. What's the derivative of cosine? The answer is negative sine. What's the derivative of c? Constant. Derivative of a constant. Derivative of a constant is always 0, so we don't need to write it. You can say plus 0 there if you want. Now look at what we have, guys. This is kind of cool. We have a sine x here, we have a negative sine x here. Those will do what? Cancel. The question is, does it check out? Did we get it right? Well, hopefully you can tell that we did. Isn't that what we started with? So guys, we want to take, if we took the antiderivative of x times the cosine of x, we got that. But if we try to undo that and we want to take the derivative of this, we should get what we started with. And we did. Okay, so kind of chew on that for a while. If you need to go back and re-watch anything, feel free. It might not make sense why we're doing this right now. I'm going to try to, next video, explain this a little bit more. All right, thanks.